I know what people really want to know from a long-range sound expert like yourself is what are the different options that are out there in the 21st century, for intel surveillance or, sports games or just the Joe Blow guy who's trying to take good video with his video camera. What are the different options for getting long-range audio in today's world?
To the best of my knowledge, there are basically four options. A shotgun microphone, a parabolic microphone, a microphone array, and laser microphones.
So just give a brief explanation of what those four, how do they operate? Because I'm guessing they don't use the same technology because there's no way that a laser microphone is doing the same thing as a parabolic. Can you just run us through a
Sure.
lay version of how these things work?
Okay. Well, most people are familiar with a shotgun microphone. It's a standard microphone element or diaphragm uh, inside or at the end of a long hollow tube. And that hollow tube that they call an interference tube, that focuses the sound so that it's only capturing sound from what's directly in front of it. There's no mechanical amplification. It's purely electronic amplification, so it'll be up to your amplifier, recorder, etc., to amplify the sound that actually reaches that microphone element. The second option then is parabolic microphones, and parabolic microphones are obviously what I'm most familiar with. You can use a wide array of standard microphones within the parabolic collector. The parabolic collector has a particular shape so that all the sound entering that dish from directly in front is focused to a single point, which is where you put your microphone. So it's actually a mechanical amplification as opposed to electronics. And then the directionality is created from the difference in amplification. What's in front of the parabolic is amplified. What's off to the side is not amplified and actually deflected to a certain extent by the dish. So that's where your directionality comes from. Then
And the fact that it's mechanical as far as amplification as opposed to electronic amplification, that's important because you get less noise within the recording. Is that correct in my understanding of that?
right, as you turn up your electronic amplification further and further and further in order to try to capture from a greater distance, you get more and more hiss, hum, electrical noise or self noise, it's often called, from the microphone and the electronics itself. All electronics has a certain amount of imperfection built into it. And that noise, as you turn up the amplification higher and higher, becomes more and more noticeable and distracting.
Okay. Sorry to interrupt. All right, what's the third one?
Okay, the third one is a microphone array. So a microphone array is an array made up of separate microphone elements, usually diaphragms. And what I've seen most often in the security world anyway is hexagonal shaped diaphragms that are then placed in a grid of one next to another. And each one of those microphones has a separate signal. And so your amplification becomes just a matter of the number of different inputs that you have can be added together. So in some ways, it's a mechanical amplification similar to a parabolic because you're taking a large number of elements with a low amplification and combining them to get a larger amplification. The directionality or focus, if you will, of the microphone array is done through electronics. So you'll have a computer or some sort of processor that takes all those different microphone elements and adds and subtracts to focus on what's in a particular um, direction or location relative to the array. So there's all sorts of computer power required, and um, it's looking for microsecond delays between one signal and the next to determine where that sound source is coming from. Then the last option is what we call a laser microphone, and you might have seen these in spy movies and so forth, where you focus a laser. It's usually on a window pane. It can really be any flat surface that fluctuates or vibrates. And as that laser beam is reflected back to its source, you measure the movement or time delay between when it was transmitted and when it was received. And that difference is used to generate a signal that then is turned into an audio signal. So it can reach extremely long distances because a microphone, or a laser rather, can shoot extremely long distances without degrading. The problem is it has to be very, very precise in its location, because if you are off target by a half a degree, by the time it goes let's say 100 yards and is bounced off the window and reflects back, a half a degree is a very long ways from where it was transmitted. So the alignment is extremely critical. So um, that's the laser microphone.